Good morning, fellow mathematicians. Welcome back to another video. Today we are going to talk about something that I have kind of teased before, spoiled before, talked about before. We're going to talk about reducing, simplifying, cancelling out, whatsoever fractions. And yeah, at first I'm going to show you at a few examples how to simplify fractions, reduce fractions, and later I'm going to tell you about a mistake many students actually do, and at the end a little bit of mathematical background why we can do what we do today. And at first let us talk about a nice little example. Let us take a look at a fraction 2/4. Nothing really special about it, it just is what it is right now, alright? But there's actually something hidden behind this fraction here. It's called prime factorization, or looking for the greatest common divisor, GCD. We are going to take a look at 4 being a multiplication of 2 or more factors where 1 is not equal to 1. It's prime factorization basically. You're going to get the hang of it. Sounds complicated at first, but it's really easy actually. We are going to try and turn the numerator as well as the denominator into a multiplication of things, because, well, fractions are just exponentiation rules written pretty nicely, and for exponentiation rules, if you deal with multiplication, turning numerator and denominator into the multiplication of things, it's actually really nice to handle. And we're going to dive right in. Using examples really does the job here. It really helps you understand what we are getting at. At first, the number 2. Well, number 2, we can't rewrite this as a multiplication of things, except for 2 being equal to 1 times 2. If you have only 1 times 2 apples, then you have 2 apples, alright? So the numerator, we are going to rewrite it as 1 times 2. Now what about the number 4? Obviously number 4 is 1 times 4, but it's also something different. We can write the number 4 as the multiplication of 2 things, namely 2 and 2. So 4 is nothing but 2 times 2. And here it goes. Now we can reduce the fraction nicely, because the 2 is up here in the numerator as a factor and in the denominator as a factor. Cancelling it out, that's like the cooking recipe here, leaves us with simply 1/2. And it does make perfect sense if you think about it visually speaking. If you have a cake turned into quarters basically, and you take 2 out of 4 quarters, well, this is exactly half a cake, 1/2. Does make sense, right, if you think about it? Let's practice with a different fraction. Let's say we are going to take a look at 15/3, what this is. So at first we are going to start off with the easiest thing, namely the denominator. Well, 3 is a so-called prime number. It can only be written as a multiplication by itself and the number 1. So 3 is just like with number 2, it's also a prime number. It's the oddest of all primes actually. There's a nice little merchandise thing I have, it's a cool merchandise piece. So 3 is nothing but 1 times 3. And what is 15 exactly? Well, 15 is 15 times 1, but it's also 3 times 5, or 5 times 3. And that's cool, right? We have the multiplication of things yet again, the numerator and denominator, and now we can cancel out the 3, said in layman's terms, leaving us with 5/1, and by the definition of the fraction, that's just positive integer, namely 5. It could happen that you can get out a fraction on the other side, or you can also get an integer basically out on the other side, like the number 5, okay? And now let us take a look at a different example. For example, what about 7/3? Well, 3, we have talked about this before, okay? 3 is nothing but 1 times 3, okay? But what is 7? Can we write the number 7 as the multiplication of 2 factors? I mean 1 times 7 always works, but okay, 2 times 4 is 8, that's already too much. No, we can't. 7 is actually also a prime number. And if you have a prime number at the top and at the bottom, it's irreducible. You can't reduce it any further. It's the lowest fraction you could possibly have. 7/3 can't be reduced. Just leave it as it is. Same with 5/1. We have a prime number in the numerator, for example, and the so-called unit in the denominator can't be reduced. A unit is just something that leaves another thing how it is. 1 times something is just a something in itself. This is something that could possibly happen. Then you can get irreducible fractions. This is what they are called. Let us take a look at different example. Number one, for example, 6 over 18. Okay, number 6, we are going to leave it how it is for now. We are not going to reduce it to lower factors in a way for now. You can do so if you want, but there's actually something easier. If you think about number 18, 18 is nothing but, well, 1 times 18, but it's also 3 times 6. So, numerator is 1 times 6, okay, rewriting it as always, and down here we are going to get 3 times 6. Aha, that works out. Okay, 6 is a common factor, even though it's not a prime number right now, it's a composite number, but it does work out, it's a common factor here, leaving us with 1/3 exactly. And thus we have reduced yet another fraction, which is cool, right? I mean, now we are going to have yet again an irreducible fraction here, and we don't need to do any more work at this point. You can get yourself a lot of examples, just try something out. There's a lot of things you could possibly do, but there's something you cannot do. I paid attention to what I said here. I said before that we can only cancel out factors. Factors are parts of multiplications. But what were to happen if we have 1 plus 3 over 3, for example? And this is a mistake that many students do all the time. What students do is they say, well, we have a 3 down here and a 3 up here. Let's cancel it out, and then we are going to get, I don't know what I'm going to get, probably something, maybe 1. I don't know at this point, but yeah, this is a mistake. This does not hold. You cannot cancel out summands, parts of summations. This is not something that works. This just has to do with our fraction as a definition of an exponential, basically. So if we have multiplication for exponentials, it does work out. It does work out nicely. This was like the 2nd episode in my exponentiation playlist. But as soon as you have addition in there or subtraction, it just doesn't work anymore. It's not good. It doesn't work out. So just keep this in mind. If you add something together in the numerator or the denominator, no, doesn't work out. You can just cancel out stuff. But you can always, if you have explicit numbers, add them together, and then you are going to get, well, 1 plus 3 is equal to 4 over 3. And this is also a reduced fraction yet again, okay, completely reduced, even though we don't have a prime number or a unit up here, but 4 is 2 times 2, and you can cancel out the 2 with a prime number down here because you don't have 2 as another common factor, just as a side note. Another side note here, okay, it's a lot of information in this video, but it's a lot of important information. What we can do is, if you have a situation like this with a summation up here, what you can always do is, if you find a common factor, for example, if we have 3 times 1 plus 3 over 3, then we have the multiplication of things up here. Even though this is something completely different, like 4, doesn't matter. We have 3 as a common factor, cancelling it out, leaving us with 1 plus 3 over 1 is 4 over 1, leaving us with 4, just as a last little side note. Okay, now we have talked about reducing fractions, talked about a lot of examples, but what about the mathematical background? For this, I would like to take a look at our first example yet again. I want you guys to notice something. We had the multiplication of stuff in the numerator and the denominator. Let us write this out here yet again. This is 1 times 2 over 2 times 2. Now, think back to fraction multiplication. What we did there is we multiplied fractions together by just multiplying the top and the bottoms together. So this is 1/2 times 2 over 2. 2 over 2. This is just an expanded fraction. We did nothing but backwards expand the fraction. We de-expanded it basically. We reduced the fraction. So for expanding fractions, we multiplied something by a 1 pretty smartly and then expanded by something that we really needed. And here in our case, we got rid of what we have expanded before. So the mathematical background behind cancelling out fractions, simplifying fractions, reducing fractions is just that we are undoing an expanded fraction. Let us take a look at 2 over 4 yet again, rewriting 2 over 4 as 2 times 1/4 And using exponentiation rules, okay, if you don't know what I'm talking about, links to the playlist will be down there in the description, leaves us with 2 times 4 to the negative 1 power for now. Okay, so we had 1 over 4 to the first power, turning the vinculum, so the fraction bar, into a negative sign, leaves us with 4 to the negative 1 power. Now, 4 was nothing but 2 times 2. So turning this into 2 times, opening parentheses, using associativity here, 2 times 2 to the negative 1 power. And now making use of the exponentiation rule, where we had different bases basically, but same exponent, okay? Dragging our exponent into each and every factor, leaving us with 2 times 2 to the negative 1 power times 2 to the negative 1 power, okay? We are just undoing fraction expansion here. Now 2 is nothing but 2 to the first power, and now we have the same base, but different exponents, leaving us with the same base, 2 to, and those exponents added together. 1 minus 1 times 2 to the negative 1 power. This is going to give us 2 to the 0th power, 2 to the 0th power, times 2 to the negative 1, and any base, except for 0, raised to the 0th power is going to variate to 1. And 1 times 2 to the negative 1 power, turning this into fraction, is yet again 1/2. That was maybe a bit quick, but if you followed everything we did and did the practice session on exponentiation, then you probably were able to follow everything I did here. Point is, for this mathematical background, when we expanded fractions before, what we did was, we have rewritten what we had here. We started off with a fraction, multiplied it by 1 smartly, 2 to the 0th power, and then just used our exponentiation rules, leaving us with an expanded fractions that we used whenever we needed it, when adding fractions together. But this time, when reducing fractions, we started off with our fraction that we had and just did the whole expansion process backwards, leaving us with a reduced fraction. So this is just a mathematical background. I hope you did enjoy this video. If you have any further questions, please leave them down there in the comments and I try to answer. I'm a busy guy, but I can try to answer. Other than that, thank you guys for watching. If you want to support the channel a bit more, recommend this channel to your teacher or classmates. And until the next video, I wish you guys a flammable day. Ciao!